Okay, I want to introduce myself first. My name is like Sung-Hoon Bang. I'm from South Korea. I am teaching the mathematics, especially the Math 141, Math 140, in 10 years at Penn State. Um, so look at Kasha, have taught in the 12 years at Penn State. So maybe she will teach it tomorrow, the like next section. So today I will teach something like that. So one more thing. I want to explain the online class very quickly to you. So if you have any question, could you write your question on the chatting board? This is the one possibility. I will answer about your questions. So I'm gonna show here. The first one. Wait a minute. Let me see. So here, we have some information about the Math 141. So you are going to Canvas. You can find this is all information of Math 141, the web course for 2018. The first, you need to buy the WebAssign. Do you know WebAssign? The WebAssign, this one. So first, you have to buy WebAssign. So you can buy WebAssign from here, purchasing WebAssign Access and ebook online. So first, you have to enroll your name on WebAssign by using class key. It's like exact class key in this section. So you can use the PSU 12224447. You just enroll your name on WebAssign. This is like the first things. The next one, you can go to like module. So we have assignment calendar here. You can click assignment calendar. So we have the schedule of the WebAssign here. I can show it to you. 8 times. Sorry, just wait. Yep, it's good. This one. The first week. This is like the reading in text on Canvas. You can find this kind of things. So we have 3 kind of things: self-assessment quiz, the like web assigned homework, the weekly quiz. So we have exact due day of self-assessment quiz, web assigned homework, and weekly quiz. Like this, you can find it. So you can take self-assessment quiz and the weekly quiz on Canvas. You can go to module, go to week 1. You can click here. The self-assessment week 1, weekly quiz 1, you can take online quiz by yourself the till due day of self-assessment quiz, weekly quiz. Was it like some the web assign? So here you can go to home. You click web assign login, like this, and then click the users only try to solve web assign homework on web assign homepage. This is like idea. So another one, the going to module again. So course structure, you can read by yourself. The getting help, you can read by yourself. We have some the exam is exactly the online exam. We can use Examily. The Examily is online exam. You just only click Examily. So this is some error here. I don't know. So sorry. You can go to home. You can click Examily student guide. You can click and read. This is like you can find details of the 2 midterm exams, 1 final exam in Examily. You can read this exam information by yourself. You can schedule some the midterm exam, the final exam, by yourself with Examily. So you can find all information of Examily in this one. And another one, the discussion board. Do you know discussion board? Here, you can click discussions. Here, you need to write your question on discussion board. I and Kasha will answer your question. Any question, you can only like write your question on discussion board. We answer your question in the discussion board. Another one, we are going to syllabus. So the textbook is Calculus, the 8th edition by James Stewart, the same. Here, learning objective, this is a very important thing. You have to focus on the learning objectives by yourself. This is a very important thing. So here, we have 2 100-minute closed book examination. So 1 comprehensive 130-minute closed book final exam. So what's like the different time? This reason is very simple. We have different points. I can explain that later. This is some of your responsibilities. You can read by yourself. So this is exact grade. Exam 1, 100 points. Exam 2 has 100 points. Homework, quizzes, 200 points. Final exam is 200 points because final exam is cumulative. So this is like the grade score. Your percentage is 93% A. Like this one, very sharp, very sharp. What does it mean? Your score is, one example is 419. Your score is like a 419. Your score is D. Your score is 420, exactly 70% like C. So we can use this grade scheme. This is academic integrity here. And this is like a course summary in here. You can check by yourself. This is like some all information, introduction part, the Math 141. Do you have any question in the general question for Math 141? I will answer your question. Could you write your question on chatting board? I will answer your question. if you don't have any question, I will go over section 6.1 today. I'm waiting. So if you have any question, could you write your question? Okay. So if you don't have any question, so I will just go over section 6.1 today. So let me see here. So could you see your slide, my slide, section 6.1 inverse function? Could you see? So if you see my slide, section 6.1 inverse function, could you write yes on the chatting board, please? Okay, good. It's good. So another one, if you have any question, always write your question on chatting board. One more, during lecture, sometimes I ask some question to you. If you know the answer, please write your answer on chatting board. We can interact together in this lecture. Okay, I start section 6.1. The section 6.1 is inverse function. So here, outline. First one, definition of a function. Second part, definition of one-to-one function. Third one, definition of the inverse function. First one, I will talk about how you can find, how you can check if a function has the inverse function or not. The fifth one, I'm going to talk about how you can find the inverse function. The last one, how can you find the derivative of the inverse function? It's like 6 topics in section 6.1. The definition of a function. What's like the definition? A function f from A to B is a relation that assigns to each element x in A exactly one element y in B. This is the definition of a function. What is A? We call the domain of f. What is B? The codomain of f. What is it like f of A? The f of A is the set of all function values f of x such that x is in the domain of f A. This is f of A. So we call f of A the range of f. So we have this kind of terminology. So one more. Was it like a notation of function? So let me see. So I can check a little bit. And yep. So here, was it like a notation of a function? The notation of a function is like this. Y equals f of x. This x value is in A domain, y value is in B, like a range. So we call y is output. This x value is input. So this is another name. Okay, the next tip, we think about one example, this one. So we have one relation f from A to B. So A has 1, 2, 3, B has 4, 5, 6, 7. So my question is, this is a function or not? So what do you think? So this relation is a function or not? So could you run your answer on chatting board? What do you think? This is a function? Okay. Okay. Yep, the two guys answers this question. So thank you. So this is a function. You always focus on these two bold one. Each element x in A exactly one element y. What does it mean? You can choose one, each element one. One is going to exactly one number 4. 2 is going to exactly one number 6. So 3 is going to exactly one number 5. Yes, this is a function. What is domain? Domain is here. 1, 2, 3, A. This whole thing is domain. What's a codomain? Codomain is whole B. 4, 5, 6, 7, like set B. What is range of F? Could you write your answer of range of F? So what is the range of F? So do you know answer of like range of F? Was it like a range of F? Could you write new answer? What's the range of F? What's the range? So what do you think? The range of F is like assigned number 4, 5, 6. We have 3 numbers. They're like this: 4, 5, 6. This is a range. Okay, next one. This is a function or not? So what do you think? This is a function? Not a function? So what is your answer? So could you write your answer? So no, no. So what do you think? This is not a function? No, not a function? So let me see. Was it like a definition of function? Here. Assigns to each element x in A exactly one element y in B. This is like a definition. So here, what happens? One is going to exactly one number 5. The 2 is going to exactly one number 6. 3 is going to exactly one number 5. Yes, this is a function. Really be careful. So 2 different numbers are going to one value, but not a problem. This is a function. This is a function because 1 is going to 5, the 3 is going to 5 individual. So this is function. Was it like a domain? Domain is 1, 2, 3. It's a whole A. Was it like a codomain? Whole B. 4, 5, 6, 7. What's the range of F? What's the range? Could you write your answer of range? What's the range of F? Thanks. 5, 6. It's good. Thanks. 5, 6. Assigned numbers. Yes. 5, 6 are the range. Yeah, thank you, all of guys. So next example. This is a function or not? No. So one guy said no. How about some other guys? To agree? No, no, no. Not a function. Because 1 is going to 4 and 5 is not going to exactly one number. 1 is going to 2 numbers, not a function. Here, 1 is going to 4 and 5. This is the reason. So you don't need to find the domain, codomain range. Definition of one-to-one function. The function f is called one-to-one function if it never takes on the same value twice. That is, f of x1 is not equal to f of x2 whenever x1 is not equal to x2. This is like a definition. So here, you can check. So this function is one-to-one or not? What do you think? This function is one-to-one? Yes? How about other guys? Same answer? Yes? 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 Okay, good. Yeah, f is one-to-one because f never takes on the same value twice. You choose different number 1 and 2. You can choose 1 and 2, different number. What happens? Function value 4, 6. Yes, different number. You choose different x values are going to different function values. This is like one-to-one. What's that? This function is one-to-one? No, 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 not one-to-one. Because f takes on the same value twice here, 1 and 3. f takes on the same value twice. The twice, this is not one-to-one. Do you know horizontal line test? Our function f is one-to-one function if and only if no horizontal line intersects each graph more than once. So this is like idea. This is graph f is like a parabola. You can draw one horizontal line, red one. We have two intersection points. This is not one-to-one because we can think about this value is like y1. So what happens? x1 is going to y1. x2 is going to y1. So f takes on the same value twice. So twice in this case, not one-to-one. So like this. F takes on the same value twice. So we think about it. The f of x equals x squared is one-to-one. This is one-to-one. No. X is no. How about some other guys? Same answer? No. No. Yeah. This is no. So because this is like a parabola, y equals x squared. You can draw horizontal line. We have two intersection point, not one-to-one. The y equals x cube is this one, this graph. You can draw horizontal line. We have only one intersection point. This graph is one-to-one. This is like a whole idea for solving this problem. The definition of the inverse function. Let f be a one-to-one function with domain A and range B. Then each inverse function, this notation of inverse function, f to the minus 1, has a domain B and range A as defined by inverse of f of y equals x equivalent to f of x equals y. So this is inverse function here. This is like exact definition. F is like given, inverse is going backward. This is like height. That's good. This is right. So here, the function f is one-to-one, inverse function always exists. Always exists. It's true. Why this is true? The one example here, 1, 2, 3, 4. 1 is going to 3, 2 is going to 4. What's that? This function is f. What is inverse function? Backward. The 3 is going to 1. 4 is going back to 2. So you can change it. Role of domain and range. So like this. This is like a curve. This is A. This is B. So we have this is B. This is A. So what happens? Inverse function exists. This is the reason. One-to-one function has the inverse function. So what kind of property do we have? So here, the was it like domain of f is A. This is exactly same to range of inverse function. The same to the range of inverse. So like this. So another one, range of f. The range of f is B. The B is the same to here, domain of inverse. This is like one property of inverse function f to the minus 1 and f, domain of inverse function. This is like one good property. The another one, you calculate composite function f inverse of f of 1. Was it like f of 1? Was f of 1? So could you run your answer? Was f of 1? So here, yeah, 3. Thanks. So 1 is going to, yep, thanks. 3, yeah, thank you, guys. 3, this is inverse of 3. What is inverse f of 3? Right, 1, thanks. So 3 is going to 1. So we have 1. What happens? Inverse of f like cancelled. So we have one good property. The inverse of f of x equals itself x. This is one good property. The another one, f of inverse of 3. So like this. What's the inverse f of 3? So we have it. Inverse f of 3 is 1. What's f of 1? Here, 1 is going to 3. So what happens? This is 3, this is 3. So like cancellation equation. We have one more property. F of f inverse of x is x. So we have these good properties. So here, domain of inverse of f is range of f. Range of inverse of f is domain of f. Inverse of f of x is not equal to 1 over f of x. Really be careful. This is minus 1 is what? Inverse. The notation of inverse, not power. Not a power. So really be careful. The not a power. The cancellation equation, inverse of f of x is x. For every x in A, f of inverse of f of x equals x for every x in B. So we have these properties. This is example. Let me see. This is a one-to-one function. F is 1-to-1. Is it 1-to-1? What do you think? 1-to-1? Yes. So as I said before, one-to-one function has inverse function. Inverse function exists. Inverse function exists. So what's like inverse function? You can change load of the A and B, like 4, 5, 6. This is 1, 2, 3. This is like B. This is like A. What happens? The 1 is going to 4, 4 is going back to 1. The 2 is going to 6, 6 is going back to 2. 6 is going back to 2. The 3 is going to 5, 5 is going back to 3. So like this. This is inverse function. Good? So like this. The next, the f is 1-to-1, inverse function exists, as I said before. Was it like A? A is here, domain of f is also exactly same to range of inverse. What's it like B? B is range of f exactly same to domain of inverse. What's it like inverse of f of 1? The f of 1 is here. 1 is going to 4. So what's it like inverse f of 4? 4 is going back to 1. So what happens? Cancelled. We call cancellation equation. F of inverse of f of 4. So inverse f of 4 is here. 4 is going to 1. F of 1. What's it like f of 1? Here. 1 is going to 4. So what happens? Cancelled. We have cancellation equation. This is like one good example. Here, inverse function exists or not? What do you think? Inverse function is exists or not? No. You're right. Thanks. So here, we have inverse relation. This is like B. This is like A. So 4, 5, 1, 2, 3. What's that? 1 is going to 4, 2 is going to 4, 4 is going back to 1 and 2. So 3 is going to 5, 5 is going back to 3. So we have it. So like this. Is right? Not 1 to 1 because inverse function, the function f is not 1 to 1. So inverse function does not exist because so one value is going to two values. This is not a function. Not a function. Inverse function does not exist. Remark. This is one important thing. F is not 1 to 1. What's the conclusion? Inverse function does not exist. Does not exist. This is like one important thing. So how can you find inverse function of f? So we have two methods. The first method is algebraic method. Step 1, write y equals f of x. Step 2, solve this equation for x in terms of y. Step 3, interchange x and y. The resulting equation is y equals inverse of f of x. That's it. That we call algebraic method. What's like a geometric method? The graph of inverse of f is obtained by reflecting the graph of f about the line y equals x. This is another one. Why this is true? What's like a main key? The main key is here. Do you remember? The inverse of y equals x equivalent to the y equals f of x. Here, what's that? Y is input in this case. X is output. What's like y? From the function f, this is output. X is input. So what does it mean? You have to interchange input and output. X is going to, the like input X is going to output. The output Y is going to input. You have to interchange the load of X and Y. This is like a key here. You can interchange load of X, Y. Here, reflect graph 1 about Y equals X. This is same, only interchange load of X and Y. So one example here. This is f of x is given. How can you find the inverse function? You can draw y equals x. You have to reflect graph of f of x about y equals x. The reflect, so we have it. This is inverse of x. Just a reflect, right? This is the whole idea. This example. find the inverse function of f of x equals x squared plus 1. So what do you think? So we can use algebraic method here. You can write y equals x squared plus 1, step 1. Step 2, solve this equation for x in terms of y. So subtract 1 from both sides. X squared equals y minus 1. The next, take square root, so like this. Step 3, interchange x and y. So we have y equals root x minus 1. This is inverse function. What do you think? This is right? This is right? This procedure right? This is answer? Is it right? Yes? This is right? This is right? What do you think? Yes, yes. Let me see. Do you remember? This is one important result. If function f is one-to-one, inverse function exists. So if function f is not one-to-one, inverse function does not exist. All right, let me check. F of x, x squared plus 1 is one-to-one or not? What do you think? F of x equals, no, yeah. F of x equals x squared plus 1 is not one-to-one. What does it mean? Inverse function does not exist. This is the idea. Really be careful. You can solve this kind of problem. First, you have to check function f is one-to-one or not. Function f is not one-to-one. No. So you don't need to find inverse function. The exact answer is inverse function does not exist. Let me see. What is f of x equals x squared plus 1? The graph is like this. Y-intercept is 1, like parabola. You can draw horizontal line. We have two intersection point. F is not one-to-one. What's the conclusion? Inverse function does not exist. So really be careful. This is the idea. Here, the next one, inverse function does not exist. So let me see. Only something like restrict the domain. So we have same function, the change only domain. So like this. X is less than y equal to 0, like a domain. Domain is given. The first, function f is one-to-one or not. Case said yes. You can interchange x and y first. Interchange x and y first. Next, solve the resulting equation for y. That's it. Yeah. Solve for y. So let me see. So if you want to sum the interchange x and y first, so you have to solve the resulting equation for y. Yeah, for y. Yes, this is possible. So I can show to you the same problem. Does it make sense, Kate? Yes, interchange x and y. The first, the next, you have to solve the equation for y. Yes, it's possible, no problem. Yep. So here, this is one-to-one. What do you think? F of x equals x squared plus 1. X is less than y equal to 0. What do you think? This is a one-to-one function or not? Yes. Is it right? Yes. Is it right? Yes. Yep. Here. You're right. This is yes. So because what is function? X squared plus 1 is, graph is like this. So what's the domain? X is less than y equal to 0. You have to ignore this portion. Exactly left-hand side. You can draw horizontal line. We have only one intersection point. Yes, this is 1 to 1. The inverse function exists. I'm going to use algebraic method. Step 1, y equals f of x. Y equals x squared plus 1. Step 2, solve this equation for x in terms of y. So you subtract 1 from both sides. So like this. So we have it. So we have two possible answers. X equals the square root of y minus 1 or the minus square root of y minus 1. We have two options, positive one or negative one. Which one is right answer? Positive one or negative one? Which one? Positive one or negative one? So what is exact x? Jesse said positive. The positive is right. So let me see. What is domain of x? The domain of x is positive or negative. What's the domain of x? Domain of x is positive or negative from the given problem. So what do you think? Negative here. The given domain is less than y equal to 0. So what does it mean? X is negative. So x is negative. Really be careful. So domain is positive 1. Yes. In this case is x equals positive minus 1 in this case. But x is less than y equal to 0. You choose negative 1. This is the idea. So like this. Because of the domain. So really be careful. Step 3. Interchange x and y. Interchange x and y. You can replace x by y, replace y by x. So like this. That's it. This is the answer. So I'm going to answer the case. You can do interchange step 23 is possible. You can do right step 1. Y equals x squared plus 1. This is like step 1. Same. The step 1. The step 2. Interchange x and y from here. So no problem. You can do interchange x and y. Yes. Step 3. Solve this equation for y. You subtract 1 from both sides. Y squared equals x minus 1. You can take the square root. Y equals square root of x minus 1 or minus square root of x minus 1. What is the answer? So let me see. You already interchange x and y. What does it mean? The domain of f is going to range of inverse. The range of f is going to domain of inverse. So this domain is going to what? Range. This is like domain of f. What's like range of f? Sorry, range of inverse function. Range of inverse function is the y is less than y equal to 0. This is like range. So range is negative. You have to ignore. So this one is inverse function. We have same answer. It doesn't matter. The either one is fine. The next tip. Was a graph of inverse function is obtained by reflecting the graph of f about y equals x. So you can draw y equals x here. Next, reflect the graph of f about y equals x. This is like 1, like this, reflect. So we have it. This function is inverse function. This function is exactly same to negative square root of x minus 1. So we have it. This is the whole idea. find the inverse function of f of x equals 3x minus 5 over 2x plus 1. Was it like step 1? Write y equals f of x first. Y equals 3x minus 5 over 2x plus 1. Step 2, solve this equation for x in terms of y. So you multiply the both sides by 2x plus 1. The 2x plus 1 is cancelled, distribute y. So we have the 2xy plus y equals 3x minus 5. The next, you solve this equation for x. How can you do that? You have to isolate x terms on one side, to isolate the other terms on one side. So we have 2x terms here, 2xy, 3x. The other term is yn minus 5. So how can you do that? You just only add 5 to the both sides. Cancel. You have to move 2xy to the right hand side. You subtract 2xy from both sides. So what happens? Y plus 5 equals 3x minus 2xy. The next, solve for x. So you factor out x from both sides. This is exactly same to y plus 5 equals the factor out x, 3 minus 2y. Next, divide the both sides by coefficient of x, 3 minus 2y. Cancelled. So we have x equals y plus 5 over 3 minus 2y. This is like step 2. Does it make sense? This is the whole idea, like this. The step 3, interchange x and y. You can replace x by y, y by x. This is like a whole idea, like this. This is a resulting equation. That's it. This is idea for finding the inverse function by using algebraic method. The last concept, the derivative of the inverse function. How can you find the derivative of the inverse function? I'm going to use one theorem. If f is a one-to-one differentiable function with the inverse function and f prime of inverse of f of a is not equal to 0, then the inverse function is differentiable at a, and inverse of f of prime a is 1 over f prime of inverse of f at a. This is the one good theorem. How can you prove? So we can use it. We can write y equals f, the inverse of f of x. So I want to change this one to this form. Use the definition. Like x equals f of y. You have to interchange input and output. So this is relation between x, the f and the inverse. Like this. Differentiate x equals f of y with respect to x. So take derivative. Take derivative to both sides. What is x prime? Do you know what is x prime? So could you write your answer on chatting board? What is x prime? X prime is yep, x prime is 1. Thanks. Is 1. The fy prime is use chain rule. Do you know chain rule? What is it like a chain rule? The chain rule is f of g of x prime, the outer function prime of inner function g of x times inner function g prime of x. In this case is f is outer function. The y is inner function g of x. You can use chain rule. Outer function prime of inner function times inner function prime. So like this. Next, divide the both sides by f prime of y. Cancelled. So we have it. The next, replace y by inverse of f of x. What does it mean? You can plug. What's it like y? Inverse f of x. You plug into the here. So this is same to 1 over f prime of f of x. So same, plug into here, f prime of x. So like this, is right? To keep this one, the prime x. So we have it. Next, replace x by a. Replace x by a, change a. So like this, so we have it. That's it. This result is exactly same to this one. What's like idea? You can use chain rule. The chain rule for finding the formula of the inverse function prime. I'm going to give you one example. F of x equals 2x plus cosine of x. Find inverse of f prime of 1. Right? So how can you find? I'm going to use formula. First, so if you want to use this formula, you have to check function is 1-to-1, 1. It's like 1-to-1. So f of x is 1-to-1. What do you think? Is 1-to-1? So 2x plus cosine of x is 1-to-1 or not? No, no. No. Let me see. Cosine of x is not 1-to-1. The 2x plus cosine of x, so far we don't know. So we don't know. How can you check? Do you know this one? F prime of x is positive. So what does it mean? The graph of f is increasing. F prime of x is less than 0. F is decreasing. So let me see. What happens in increasing function? The function is like an increasing function. You can draw a horizontal line. What's that? This is always 1-to-1. The function f is decreasing function. You can draw a horizontal line. We have only one intersection point. Yes, this is 1-to-1. So how can you check the f of x is 1-to-1 or not? You can check. Graph is increasing or decreasing. You can check these kind of things. This is like idea. You can take a derivative. F prime of x is 2x plus cosine of x prime. What is 2x prime? What is 2x prime? Yeah, 2, thanks. What is cosine of x prime? What is cosine of x prime? Yeah. Yeah, thanks. Yeah, negative sign. We have 2 minus sine x. You can check. The 2 minus sine x is positive or negative. So what do you think? The 2 minus sine x is positive or negative? Always positive. So because sine of x is between negative 1 and 1, you plug smallest number into here. 2 minus negative 1 is, yes, positive. You plug largest number sine of x into sine x, 2 minus 1 is 1. This is also positive. What does it mean? You can plug minimum value or maximum value into sine of x. The 2 minus sine x is always positive. So we have this is always positive. So f is increasing. Increasing function is 1 to 1. Yes, this is 1 to 1. We can use formula. Inverse of f prime of 1 is 1 over f prime of inverse of f of 1. Can use it. Step 1. You can find inverse f of 1. You can calculate. This is like unknown x. I want to use definition of inverse function. Change it to the f of x. The 1 equals f of x. What's it like f of x? F of x is 2x plus cosine. You plug into here. 1 equals 2x plus cosine of x. What is x? What is x? So what kind of number satisfies this equation? 1 equals 2x plus cosine of x. What is x? So what do you think? So you think about it. What is x? So which number satisfies 1 equals 2x plus cosine of x? So what is x? 0? 0? The Bob said 0. So what do you think, other guys? 0 is possible? You plug 0? Yeah, right? 0? 0? Yes, x is 0. Thanks all of guys. You plug 0 into x, so what happens? 1 equals 2 times 0 plus cosine of 0. So 2 times 0 like 0, cosine of 0 is 1. Yes, 1 equals 1. This is answer, x equal to 0. So we have x equal to 0. So next step, you plug x equal to 0 into here. So we have 1 over f prime of 0. You calculate f prime of 0. How can you find f prime of 0? F prime of 0 is, you plug 0 into here, derivative. 0 into here. 2 minus sine of 0. What is sine of 0? So what is sine of 0? Sine of 0 is 1, 1, 0, 0. So really be careful here. Cosine of 0 equal to 1. Sine of 0 is 0. Opposite. Cosine pi of 2 is 0. Sine of pi of 2 is 1. We have different answer. This case is 0. 2 minus 0. Right? So what is the answer? 2. You plug 2 into here. What's your final answer? We have the 2 so far. So we have it like this. Step 3. So previous one is 1 over f prime of inverse of f1 is like x. X is 0 here. F prime of 0 is 2. We have 1 over 2. That's it. This is the whole idea. Only reciprocal. From step 2. The last example. F of x equals the square root of x cubed plus x squared plus x plus 1. Find inverse of f prime of 2. So f is 1 to 1. You can check. How can you check? You can take derivative. How can you calculate this kind of things? You can use power rule. The first one, you change it. X cubed plus x squared plus x plus 1. Change it to the power form. Power 1 half prime. How can you calculate? So do you know this one? G of x to the power n prime. Like a power n is down. G of x to the power n minus 1 times inner function prime. So the like root of n is 1 over 2. So we have 1 over 2 x cubed plus x squared plus x plus 1 to the 1/2 minus 1 times inner function x cubed plus x squared plus x plus 1 prime. So simplify. 1 over 2, you can change it to the negative things. So like this, times. What's x cubed prime? 3x squared. X squared prime is 2x. X prime is 1, 1 prime equal to 0. So change it to the positive exponent. This is 1 over x cubed plus x squared plus x plus 1 to power 1/2 times 3x squared plus 2x plus 1. You can change it to the radical form again. The numerator is this one. So 3x squared plus 2x plus 1. We have 3x squared plus 2x plus 1 over 2 times square root of x cubed plus x squared plus x plus 1. You can change it like this. Right? This is always a positive number. You can just sketch the graph. 3x squared plus 2x plus 1. Graph is like above x-axis. So this value is always a positive. F is increasing and 1 to 1. You can use formula. What's like the first one? You calculate inverse f over 2. This one. This is unknown x. This is inside 1 is unknown x. You can use definition. 2 equals f of x. What's like f of x? F of x is the square root of x cubed plus x squared plus x plus 1. So what is x? So what is x? So what do you think? You can guess. So what is x? So 2 equals the square root of x cubed plus x squared plus x plus 1. So what is x? Is it 1? Is it 1? So what do you think? 1 is right? Is it 1? Is it 1? Yeah, root 4 is 2, 1. Yeah, thank you. The other guys. So you plug 1. Yes, this case is x is 1. You plug 1 into here, 2 equals like a square root of the 1 cubed plus 1 square plus 1 plus 1. So 2 equals root 4. 2 equals 2. Yes, x equals 1. The step 2, you plug 1 into here. So we have 1 over f prime of 1. How can you calculate f prime of 1 here? F prime of 1 is, you plug 1 into here. Plug 1 into derivative things. Plug 1 into x here. So we have 3 times 1 square plus 2 times 1 plus 1 over 2 times square root of 1 cube plus 1 square plus 1 plus 1. What's the numerator? 3 times 1 square is just a 3. 2 times 1 is 2. So exactly 3 plus 2 plus 1, 6 over 2 times square root of 4. This is 6. 2 times 2. 2 is crossed out. Answer is 3 over 2. Was it like step 3? You need to find exact things. This one. So what's that? So this part is here exactly 1/3 the exactly reciprocal. So we have 1/, you plug 3/2 into denominator, and reciprocal is 2/3. That's it. This is like finally for solving this problem like this. One more. So I will upload this lecture note. This lecture note on Canvas. You can find my lecture note on Canvas. So this is some of Tuesday lecture. So if you have any question, write your question on the chatting board. I will just answer your any question. So if you don't have any question, you can leave Zoom now. So if you have any question, you can write your question on chatting board. I just waiting. Oh, you're welcome. Oh yeah, the same things. I will post this recording lecture on Canvas. Yes, you can find. You can find the exact this lecture on Canvas. You can watch this live section by yourself. Yeah, I will post. Yeah. So you're welcome. Thank you. Have a nice day.